welcome back to online classes. Today we will be doing chapter number 6, square and square roots. Important topics: finding square root by prime factorization, finding square root by division method, some questions from the exercise, and properties of perfect square. Let's start with the properties of perfect square. A number ending in 2, 3, 7 or 8 is never a perfect square. Second, square of an even number is always square, is always even. That means 2 square is 2 to the 4. So 4 is even 2 is even. 8 square, 8 is 64. 8 is even number, even 64 is even number. Number 3, the square of an odd number is always odd. Example, let us take 3. 3 square, 3 3 is 9. 3 is odd, even the square is odd, 9. 7 square, 7 7 is 49. 7 also odd, and its square also is 49. That is also odd. Next, for every natural numbers n, we have n plus 1 whole thing square minus n square is equal to n plus 1 whole thing bracket plus n. That means 36, suppose we take 36 square minus 35 square, it is equal to 36 plus 35, that is equal to 71. Number 5, every natural number n odd numbers, that is n square. Suppose you are given odd numbers and you are asked to find out the square or sum of the numbers without multiplying or adding. So what do? We count the number of odd numbers and square it. Like here 1, 2, 3, 4, 5. 5 square. The total of these numbers will be 5 5 is 25. Next, to find out Pythagorean triplets. For every natural numbers which is m greater than 1, we have 2m comma m square minus 1 and m square plus 1. These are known as Pythagorean triplet. In this case, we'll first use 2m to find out the value of m, and after that m square minus 1, m square plus 1, we will get the 3 digits which will be known as Pythagorean triplet. Between two consecutive numbers, we have 2n non-perfect squares. Okay, so suppose we take any numbers, the first number will be taken as n, and if multiplied 2 times, the total number of non-perfect square will come between the given number and the consecutive next subsequent number, like 11 and 12. So we'll take n as 11 and multiply 11 by 2. So 2 11s are 22. So there will be 22 non-perfect square between 11 and 12. Next, the square of a proper fraction is smaller than the fraction. That means whenever you take 1 by 2, suppose for example, and square it, it will be 1 by 4. So 1 by 4 will be smaller than 1 by 2. Last, a number ending in odd number of zeros will never be a perfect square. For example, 1000. 1000 has 3 zeros. So it will not have perfect square. But you take example 100. 100 has 2 zeros that are even. So its square root will be 10. So zeros ending with 2, 4, 6, 8 will have perfect square. But zeros ending in odd 3, 6, 9, 3, 9, 12, 15, 19 like that will not have perfect square. Now children, I will take one question using Pythagorean triplet. I will find out the numbers. Like here, question number 2 of this exercise mode 2. Write a Pythagorean triplet whose one of the member is either 6, 14, 16, 18. I will take the first part whose one of the number is 6. For any natural number, as I said, m greater than 1, we will use 2m first to find out the value m, and then m square minus 1 and m square plus 1. Okay, let 2m be the first number that we have taken, is equal to 6. M equal to 6 divided by 2, m is equal to 3. So we have found the value of m using 2m. Now we will use any one of them, m square minus 1 or m square plus 1. I have taken m square minus 1. M means 3. So 3 square minus 1. What is 3 square? 3 3 is 9. Minus 1, 8. M square plus 1 means 3 square. That is 3 3 is 9 plus 1. That is 9 plus 1, 10. So therefore the Pythagorean triplet are 6, which is already given in the question. Next is 8 and 10. Now I will take one question from the exercise, same exercise 6.4, question number 4, and here we will explain you the division method of square root. The question is, find the least number which must be subtracted from each of the following numbers so as to get perfect square. Also find the square root of the perfect square so obtained. First we'll try and find out the square root, and if any remainder is there, then we will subtract it from the number and then find the actual perfect square number. Let's take first one. There are 3 parts. I will take first one, 402. So first 402, we'll draw one vertical line, another horizontal line, and take 402 inside. Now what do? We will we'll group them from moving from right to left, taking 2 at a time, 2 numbers at a time, because square means 2, cube means 3. So square 2, that is 2 and 0. It means unit digit and 10 digit, one bar, one group. And the remaining 4, which is in the hundreds place, will be our second group or second bar. So there are two bars or two group. First, moving from right to left, 0 2, and second group is single 4. Now to get 4, because it's square root, we'll take numbers in square, same numbers 2 times, like 2 2 ja 4. Write 4 here. 4 minus 4, nothing. Okay, then take the next group, 0 2. Here what do you do? Add this 2 plus 2, 4. So what do we do? Multiply 2 and 2, we write inside, and add 2 and 2, we write just below this line. Now what do you think? Here, because this number is smaller than the two given number, so what do you do? We take 0 time 0, and we will multiply it 0 by 0 only. So when I take 0 here, it becomes 40. Because I have taken 0, I will multiply 40 by 0. So 40 zeros are 0. Once again we subtract, you get 0 2. So the remainder here is 0 2. It means, since the remainder is 0 2, it means 20 square is smaller than 402. So it is not a perfect square. Your quotient which you got here is smaller than the dividend that you have here, because we have remainder. Therefore what do you do? We subtract according to question. 0 2 is the remainder. So this is the number we have to subtract from 402. So 402 minus 0 2 is 400. This is the number whose square root will be perfect. So 400 perfect square is 20. Now children, I will do finding square root by prime factorization. First I take 729. 729, because this can be divided by 3. So 7, 3, 243 ja 729, 3, 81 ja 243, 3, 27 ja 81, 3, 9 ja 27, 3, 3 ja 9, 3, 1 ja. Now all these are prime factors. I will collect all them here. Right, 729 is equal to the prime factors, 3 into 3 into 3 into 3 into 3 into 3 into. Okay, now I group them with a pair of 2, group of 2 numbers. That means 1, 2, 3. There were 6 threes, so I have 3 groups. From each group I take 1 digit. From each group I take 1 digit. From each group I take 1 digit. We have 3 threes. So I multiply them. 3 3 is 9, 9 3 is 27. Therefore square root of 729 is 27. One more, 7744. First I draw one vertical line and one horizontal line. I write 774 here. Okay, and start with 2. 2 3 8 7 2 ja 7744. 2 1 9 3 6 ja 3872. 2 9 6 8 ja 1936. 2 4 8 4 ja 968. 2 2 4 2 ja 484. 2 1 2 1 ja 242. Then 11 11 ja 121. 11 ja 11. Now I collect all these prime factors here. 7744 into is equal to 2 into 2 into 2 into 2 into 2 into 2, 11 into 11. From each group 2 2, this 2 2, this 2 2, from this 11 11 I take 1 1. 1 2 from this group, 1 2 from this group, 1 2 from this group, 1 2 1 11 from this group. Now I multiply. 2 to the 4, 4 to the 8, 8 11 is 88. Therefore square root of 7744 is 88. Now children, having finished explaining the chapter, I will give you the homework. The homework is find the square root by prime factorization. 15,876 and 17,424.